All right, make sure that you put your first and last name at the top of your packet, please. This week, the items that are due, of course, is your warm-up. If at any time you are absent, please go back and watch the daily video so you can get the answers to the warm-ups, okay? Or assistant with the warm-ups, some assistance. Your homework is due this week. You have homework. Again, if you're missing something, sometimes we go through that on the daily video, and other times I might do a homework help. All of which would be on Canvas, okay? Or Remind. These are due on Friday. Okay, please make sure, so that you're not overwhelmed, that you do homework nightly. We have a mixed review that is going to be due. We're going to submit that in Canvas. So we have mixed review. It's a worksheet. Need to make sure that that's due on Friday. Oops. And we're going to submit that on Friday. Go back and look at your notes in your interactive notebook. If you need help, you have notes in your interactive notebook to help you with the mixed review. Right now, I don't have a scheduled quiz, but if something changes, if I'm able to complete what I need to complete for this week, then we'll have a weekly quiz on Friday. But right now, we don't have one that's scheduled. But I will let you know if it changes. Today, we're gonna write down our EQs. We're gonna work on our warm up. We have notes on functions, and they are going in our interactive notebook. Our homework is going to be set 6A. You need to make sure that you show work on a separate sheet of paper. Any questions? Pause for the pause. All right, let's write down our essential questions. I'm going to read them off my Canvas page. So I'm going to pause here. All right, so let's look at the warm-up. Don't forget here, when you do this problem, you're supposed to distribute the negative. Don't forget that. It's negative on the outside, distributed negative. So this is 2v plus 18. This is, 19. I thought I was going to call for a sneeze or something. It didn't even come. A negative times a negative is a positive. A negative times a negative is a what? Positive. Okay. Now what are we going to do next? Yes. Move the variables to the same side. Which one do y'all want to move, the 2v or the 4v? 2v. How do you move a positive 2v? Subtract 2v on both sides. Good job, y'all. So when you subtract 2v, this is gone, and we're left with 19. Bring down the less than sign. 4v minus 2v, what is that? 2v. And then here, this gives us what? Now what do we do to get v by itself? Subtract 7. When we subtract 7, what does that give us? 12. That gives us 12. Bring down the less than 2v. So I'm going to write that here. 12 less than 2v. Now what do? Divide by 2 on both sides. And what does that give us?
6.
6 less than what? What's another way to write that? Or what?
Or b is greater than 6.
Very good. Okay. This equation, instead of writing y, they write f of x. Y is the same as f of x. Okay. They are. Can y'all please shut up so I can explain it? Jesus. You quick to say something don't make no sense instead of just listening. All right. The reason why they write it as f of x is because in order for you to get the value of y, you have to know what x is. So what they do is they put a number here for x. Okay. And what you do to solve for y is you plug in the number for x. So that's why this is why they say that. They say y is a function of x. Because in order to figure out the answer for y, you have to know the value of x. You can't solve y without knowing x. Okay? So that's what this is. This is written in function notation. So all they're telling you is find y when x is equal to -2. This is what this is saying. Find really is saying find y when x is equal to a -2. Whatever number is in the parentheses is going to be the value for x, or it's going to be the number that you're substituting. Because sometimes they don't always use x. Sometimes they use n or p or t or q or r. Okay, so whatever they decide to use, the number that's in the parentheses, you're going to substitute that number into and to find the answer. So to find the answer here, or to find y here, you're going to plug in -2. So this is f of -2 is equal to, let's plug in -2. So this is -2 times -2, that's what x is, plus 4 times -2 minus 3. All you're doing from here out is just using order of operations to figure out the value of y, or f of -2. So here, first thing is multiplication. Yes.
It's -2x cubed. -2x.
Oh, this is a cube. Okay, you gotta say, I don't know what you was talking about, to be honest. All right, so what's the first step here? Yes.
Do you do the exponent?
You do the exponents first. So out to the side, how do I write -2 to the third power? How do I write that? -2 times -2 times -2. What's -2 times -2? Positive 4. Good job. Times a -2. What's that?
-8.
That's -8. Anytime the exponent is a positive, it's going to be a positive answer if it's negative, okay? When it's an odd number, then it's going to end up being a negative answer. So you don't have to sit there and just guess, oh, is it going to be a positive or a negative? If it's odd, it's going to end up being a negative, because two negatives, when you think about it, is going to give you a positive when you multiply, okay? N? Yes. All right, so this gives you a -8. So we get -2 times -8. We can go ahead and multiply this together. What's positive 4 times a -2? This is also a -8. And then we bring down the -3. So all we're doing is order of operations. What's the next step here? What are we going to do next? Yes.
Multiplication.
Okay, and what do you get when you multiply?
You're going to do -2 times -8, and that's going to give you 16.
Great job. Bring everything else down. Okay. What's going to be the next step here? Somebody different? Because he's already, guess it.
16 minus 8.
And what does that give you?
8.
Okay, so this is 8 minus 3. And so what's our answer here?
5.
5. Okay. All right, this is a literal equation. Remember, a literal equation is an equation that has more than one variable. How do we solve for b here? What are we going to do to solve for b? Yes.
You can multiply by 3 on both sides.
Very good. To get rid of this 3 that's being divided, We're going to multiply both sides by the 3. So what are we going to get on this side of the equal sign? Yes, 3a. Very good. And on this side, what are we going to get? Yes.
A plus B plus C.
A plus B plus C. Oops, sorry. My bad. Okay. So now what do we do to get B by itself?
You subtract A
You're going to
and you subtract C.
Okay, we can do them both. There's no harm in that. As long as we know what we're doing. Oops, I said A twice, y'all. When you subtract them both, on this side, you're going to get 3A minus C. Can't combine them. They're not alike. This is going to cancel out. This is going to cancel out. And we're just left with B. Or you can say B is equal to 3A minus C.
Wouldn't subtracting A make it 2A?
Where? Oh, these are not the same. This is a capital A. This is a lowercase a.
Oh.
They're not like terms.
That used to always confuse
Yeah, it's okay. Now you know little a and small a are different. This is like big B, little b. Big B in some problems means the area of the base. The little b just means the base. They are two different meanings. Okay? They are not the same. All right, so here we go. Let's look at this. Let's multiply. We multiplied because these parentheses, no operation here is multiplication. So let's multiply the numbers first. What's 18 times a half? It's 9. We did that first. Now let's do the x's. Okay, so this is 9. Probably should put this over to the side. 18 times 1/2. All right, let's do x to the 3rd times x to the 6th. What's that?
X to the 9.
X to the 9.
X to the 9th. You're going to say 3 plus 6. X is being multiplied 9 times. You got y here times y to the 5th. If you don't see an exponent, what is the exponent automatically here?
1.
1. So what's this answer going to be?
Y to the 6.
Y to the 6. You're going to add, and that gives you y to the 6. Any questions about that? Yes, baby. Yes. All right. Any question? Yes, baby. I'm sorry.
Can you re-walk me through half that?
Which one? Like this part right here? The numbers you multiply together, you got 9. Then the x's, x to the 3rd and the x to the 6th. X is being multiplied 3 times here. Then x is being multiplied 6 times. So it's being multiplied a total of 9 times. Does that make sense?
Is it like distributive property?
No. I wouldn't say that because that'll be kind of confusing. Do you know what an exponent represents? If you have 5 to the 3rd power, what is that saying? 5 times 5 times 5. That's the same thing that these are saying. I'm multiplying x 3 times here. I'm multiplying x 6 times here. So how many times is x being multiplied all together?
9 times.
That's why that's 9. You got it? And then this one is saying x is being multiplied 1 time. Bless you. And x is being multiplied 5 times. So that means x is being multiplied a total of how many times? 6 times. That's where I get that from. Did that make sense to you? Are you okay?
Yes.
Okay. All right. I'm paused for the calls. Give you a chance to write. Please take out your interactive notebook. Okay. So let's look at this one. We are on page, I forgot what page we were on. 23. Is it 23, y'all? That was literal equations. 20, that was 22. Literal equations is 23. You're right, 23. All right, so we got Q1, page 23. And this is going to be functions. I think functions is easy. You'll be able to tell in a minute. Some of this you might already know and didn't realize you already knew it because it's just the name. Okay, so people get confused with technical names, and a lot of times when you teach 6th grade and 7th grade, you don't have to say all of the names. You give them the basis of it because you don't want to confuse them, and then as they get older, you start being more technical. Okay. All right, so here we go. First definition that we need to do is relation. Okay, a relation. A relation is a set of ordered pairs, okay? Whether the ordered pairs are just listed in a group, they could be listed in a table, X and Y table. What else? Or it can be graphed on a coordinate plane, okay? So ordered pairs, we could say they could be in a table. The table could look like this. They could just be in a group where it's just a group of ordered pairs where you have X and Y. Or it could be it could already be in the graph. The points could already be graphed. And it would be all of the points that are on this line. These are examples of relations. It's just a set of ordered pairs, whether they're in a table, in a group, or they already graphed. A function is where your x values, yes, baby,
Slide up.
is where your x values in a relation do not repeat. Where the x values in a relation do not repeat. All right. So now let's do some examples of that. I'm going to give you some relations, and we are going to see if it is a function or not. Okay. So let's do some examples. All right. The first example, I'm going to do a relation, but this relation is going to be in a group. And this is this relation a function? Okay. So number one, we're just going to do a group. We're going to do a list of ordered pairs. We have this list. We have 1, 3. That's an ordered pair. 5, 6, 8, 2, and 11, 14. We want to look at this relation, which is a set of ordered pairs, to see if it's a function. How do you know when it's a function? When the x values do not repeat. So we're going to underline all of our x values or our domain values. So we have this is x, this is x, this is x, and this is x. Do any of these numbers repeat? 1, 5, 8, 11. Do they repeat?
No.
Then this relation is a function. Why is this a function? Because the x values do not repeat. Do not repeat. Got it? Come on now, stay with it. Number 2, let's look at this relation. This relation is going to be in a table, okay? We got a table. We got our x values and we got our y values, okay? Our x and y values. We have 3, -1, -6, -10. We have 8 and 2. We have 6, and we have -15, and we have 11, and we have 12. Okay? Now we're going to look. We're going to look and see if this relation is a function. Any idea? Is this relation a function? Yes or no?
Yeah.
Yes. Why is this a function?
Because the x values do not repeat.
Because none of these x values repeat. Okay? So this is a function. This relation is a function because the x values do not repeat. Okay? See if you can do these. See if you can do these. Oops, sorry. Yes. All right, I'm gonna stamp if it's right. Okay, if it's not right, then I'm not gonna stamp it, okay? If you're ready, you can hit by raising your hand off into a lot of people. Oh guys, we need to just say if this is a function or not. Okay. Because you need to focus. You need to listen. You need to be listening. You need to listen to the preacher. I don't know what you mean. Is it a function or not?
Yeah.
Yes or no?
Yeah. If I put function and it and in relation to cycles.
Is this a function? Yes or no?
No.
Okay, I'm putting not a function. Is this a function? Yes or no? So you got it. Wait, right? Make sure you use pencil just in case you mess up.
I just forgot.
And I think it might be pencil. I don't know what you mean by that. Is it a function or not?
Oh,
They're all going to be relations, okay? They're all going to be a relation. I'll be for them. Oh, okay. Oh. Where's the other one that we did? 1, 2, 3, 4. Oh. What you got? Is it right? You got all of the S function or not? Well, yeah, 50-50, right? You got it now? Okay. It's in a 50-50.
Yes.
I'm sorry. All right. Okay, so let's do it. Most of us got it right. Okay, with some minor errors, but that's okay because we're still learning, right? Okay, so here, look at this. Our x values here are repeating. You see? Look, this is x, 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 x. You got two that repeat, so this is not a function. Okay? Here, look at all your x values. None of these repeat, so this is a function. Look at all these x values. None of these repeat. They're all different. So this is a function. Any questions about that? Yes.
So like functions are like what x value?
The functions is where every single x value is different.
Oh, okay.
If the x values are the same, then it's just a relation. It's not a function. You got it? All right, so let's do where it's a graph. So now we are finding the relation, seeing if the relation after the point's a graph to see if it is a function. So this is how you do that. Which number is this one? 6 or 6? All right, so let's do this graph. This is going to be a little different, so I'm going to model for you how to do this. This is a relation. They've graphed all the ordered pairs. So in order to figure out if this is a relation, you have to see if any of these x values on this graph is the same. Okay, in order to do that, you use what is called a vertical line test. So star, use the vertical line test to see if a graph is a function. Now it's spring. That was at like 8 o'clock this morning. Unless somebody's using my printer. All right, so let's do this. A vertical line test, or the vertical line test, is where you're going to take a vertical line, and remember your vertical line goes up and down. So when you do the vertical line, you take a vertical line and you see if the graph passes through this vertical line more than once at the same time. Okay, so I'm going to write that down for you so you know. Vertical line test. This is where you use a vertical line. And remember, vertical line is an up and down line, just like this, to see if the graph crosses the vertical line more than once at the same time. Other way around. All right, watch me do it. Watch me do it a couple times to see if you get it. And the craziest thing about these is that I wish I had usually what I use is spaghetti noodles because they so thin and it's better to use spaghetti noodles. I know by looking at it, but when you're first starting off, you're not gonna know by just looking at it. All right, so you take a vertical line such as a pencil, and you wish that it was thinner, but you move that pencil from left to right. And what you notice as you move the pencil from left to right, you're going to see if the line loops back around and touches the line at the same time. So as I'm moving this line through, I notice that so far the line is only touching it once as you move it through. It doesn't loop back around and touch the line twice at the same time. It only touches the line once at the same time. So this right here is a function because of that. This passes the vertical line test, so this is a function. Yes, babe. Gosh, oh God. We just went to the bathroom like not too long. You don't go to the bathroom at lunch? Go ahead. It's like 50 people that actually go to the bathroom. All right, this is a function because it passes the vertical line test. Yes, babe. Well, we're gonna do more examples.
Not do more. Like
We got to, because just going over the same one, you're not gonna get it. You have to do many more examples because they're all gonna look different. You're not gonna have a line that look like this all the time. They're all gonna be so different because as you move this line across this particular line, you look at the squirrel. It doesn't loop back around and touch the line twice. It's only touching the line once as we go by. It touches it here, then it touches it here. So the only way for you to know it is that you do an example of a function, and then you do an example that's not a function. So then you make comparisons. Oh, I see why this one is a function and this one is not. Does that make sense what I'm saying? You're not going to get it by just looking at one. And I'm going to do this one real quick because I got 1 minute. Number 7. You have a line that looks like this. You're going to use the vertical line test. That means you're going to take your vertical line, you're going to move it across the line to see if the vertical line, if the graph touches the vertical line in more than one place. And look here, this is where this makes sense. Watch. You see my line, my graph? The graph touches my vertical line in 2 places. Up here and down here. Do you see that? So this is not a function because it touches this vertical line in more than one place at the same time. This one is not a function. Do you see that now?
Yeah.
It fails the vertical line test. All right, it's not time to go, honey. It's not time to go. Oh, that joker. I forgot about him.